To find the partial fraction decomposition of the given fraction, you need to break up the denominator into factors, right? You need to factor the denominator. Notice that you can first start by x plus 1, and then you're going to have x to the third plus x squared plus x plus 1. And this factors further as x plus 1 times x plus 1 times x squared plus 1. So as you can see, you have two repeated linear factors, prime factors, and also you have a quadratic prime factor. This cannot be reduced any further, right? This is an irreducible factor. So all of these are prime. Two linears and one quadratic. Now, so here's how you break this up. So you're going to have three respective fractions. The first fraction will be the constant divided by the first factor. Now here's where you got to watch out. You might be tempted to just write x plus 1. But whenever the factor is repeated, you have to raise the power by 1, right? So it's going to be squared. Okay? So you had x plus 1 to the first power for the first denominator. For the second one, you will set it to the second power, only because there are two factors that are repeated, right? Whenever it's the same factor, remember that you're going to square. If there were three factors like that, the next constant c would be divided by x plus 1 to the third power, etc., and on and on. Okay, so this is the rule. Now, when it comes to the quadratic prime factor x squared plus 1, you're going to have two constants. The first constant must be multiplied by x, and then the second one by itself. Okay, this will be x squared plus 1 on the bottom. And again, this is true for quadratic prime factors. Whenever you have that, you're going to have two constants. One of them will be multiplied to the x, and the other one will be by itself. Okay, so you need to find a, b, c, and d in order to find the partial fraction decomposition of the given fraction. So now, as you know, the next step would be to realize that if you multiply both sides of this equation by the denominator, or by this, only the top remains on the left side. And realize that if you multiply this side by this, one of the x plus 1s will be gone for the a, so a only multiplies by these two factors. Okay, so a multiplies by x plus 1 and x squared plus 1. Then the b multiplies, it already has two factors of x plus 1, right? So it needs to be multiplied only by this one, x squared plus 1, the quadratic prime factor. Then the cx must be multiplied by these two linear factors, okay, because it has only x squared plus 1 factor, quadratic factor beneath it. Right, so it's going to be x plus 1 and x plus 1. Okay, and then finally the d multiplies the same thing, right? X plus 1 and x plus 1, just like the c did, except it doesn't have the x. Right, so x plus 1 and x plus 1. Okay, we're going to write the left side as it is, and the right side we're going to try to group together. So x to the third is the highest power, right? So let's group x to the third constants together. So we know that a multiplies x to the third because of the first product. So a plus b does not have x to the third, x power, so we let it go. The c does, right? Because it has three x's here. X, 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 right? So plus c. And d doesn't, right? So that's it. Now x squared, what about that? Let's group things together, right? So x squared definitely has a term, right? X squared also has a, right? So a is there, plus b definitely multiplies x squared, so plus b. C plus 2x, so plus 2x squared for the c, right? So plus 2c as a result if we take the x squared out, right? So that's going to be that. And actually we forgot the d, so plus x squared is the first product for the d, okay? Plus x, let's see what we have for the x power. We have 1x for the a, right? So we can do that. So A, we have no 1x for the B, so we skip that. We have 1x for the C. The last product is 1 times this x in the front is C. And then we have 2x's to the first power for the D, right? 1x plus 1x. Two products give you 2x, right? So plus 2D happens to be what we have. And then the constants, let's see what the constants are without any x's to the first power, second or third power. Just the numbers. These are going to be A, because 1 times 1 is there, right? So A. The B, as you can see, 1 times B. And then that's out because C is already attached to x. And D also has 1 times D, right? So plus that. Okay, so now we can compare coefficients for the respective x powers. Start with the highest power, x to the third. We have a coefficient of 2. So 2 will be equal to whatever is going to be multiplied to the x to the third power. And this is going to be this, right? A plus c. So a plus c is equal to 2. Now x squared power, there's no x squared power on the left side, so it's going to be 0. And here we're going to have a plus b plus 2c plus d. Okay, and I'm actually going to move this guy here. Okay, and I think okay. So now the next one is going to be x to the first power. X to the first power is going to be what? There's minus 4 coefficient on the left side. And we have a plus c plus 2d. A plus c plus 2d. And finally the constants, which is x to the 0 power. There are no constants here, so we just set 0 on the left side. Here we have a plus b plus d being the only constants without any x's attached to them. X plus b plus d. You see I'm vertically aligning them because it would be easier to work with that. So here's what I see. I see the first equation and the third equation that we can work with. Realize that a plus c is equal to 2. So we can substitute a plus c is equal to 2 here and solve for d as a result, right? So minus 4 is equal to 2, because this thing is 2, a plus c is 2 according to the first equation, plus 2d. You see that isolates the d as the only letter that we're going to solve for, the only constant. Subtracting 2 is minus 6. Minus 6 divided by 2 is minus 3 for the d. So d is minus 3. That's a good one. So the next what I see that we're going to work with is the equation 4 and equation 2. Since we know the d value, a plus b will be a certain value, and then we can plug that a plus b value into this equation, and we also know the d, so that means the c will be the only one that we will need to find. You see? So we know a plus b was what? Since d is negative 3, a plus b must be 3, right? So now we're going to plug this a plus b into the second equation, and we also know the d value, so we can find the c, right? So 0 is equal to 3 plus 2c minus 3 for the d value. So look what happens. 3 minus 3 is 0. So that means 0 plus 2c is equal to 0. So that means that c is equal to 0 if you solve this. So c is equal to 0. Good. We already have two letters that we solved for. Now c is equal to 0 prompts you to find the value of a, because a plus c is equal to 2. So that means if c is 0, we disregard it. So that means a is clean 2. A is equal to 2. So a is equal to 2. So now using this equation, we can find the b. Because if a is equal to 2, subtracting 2 from 3 gives us 1 for the b value, right? So the b is 1. Okay, so this successfully found all constants that we needed. So now the answer to this would be what? 2 over x plus 1 plus 1 over x plus 1 squared plus, let's see, what is the c value? The c value is not there, so we skip it. We just find the d, and the d was minus 3. So minus 3 over x squared plus 1. So hopefully this was fun. Thanks for watching, and I'll see you in the next video.